and welcome to the 7Compact calibration video. Meet Helping Hans, your guide for today. Say hello, Hans. Hans is just a pair of hands, so he can't talk. But don't worry, he knows the equipment inside out. He's very hands-on and keen to hold your hand through the process. So, the 7Compact pH meter. It's really flexible and easy to use, combining precise electrochemical measurement technologies with flexibility, innovative design, and ease of use. I think that's enough from corporate Hans. Why don't you go ahead and show them exactly how to use the meter? So, you want to measure the pH of your samples. Want to check everything is in hand and you're not too acidic or too alkaline. But wait! Stop, Hans. If you want to take accurate measurements, you must calibrate before you use the sensor. Okay, right. Calibration. How to explain? This is basically correlating the real-life output of a sensor with a hypothetical sensor that works perfectly according to theory. As the sensor naturally degrades with age, its real measurements will deviate from the correct theoretical value. Calibration accounts for the deviation to allow accurate measurements. Too scientific? Yeah, okay, sure. How about some music instead? Ouch! Calibrating your sensor is kind of like tuning a violin. You take a tuning fork which has a fixed pitch value, and you tune the violin until it replicates this pitch, and the music you play sounds as it should. In our case, the violin is the sensor, and the tuning fork is what we call a pH buffer. These guys. Hans, please tell me you weren't just drinking the pH buffers. I told you it's really not good for your health. Okay, put that away now, Hans. We're here to do some work, not write a symphony. Now that we understand that calibration is extremely important, we can get started. You will need the meter, obviously, a sensor, a set of buffers, some distilled water, some lab-style tissues, and of course, a safe pair of hands. When you have everything you need, it's time to build the equipment. Plug in the sensor and its temperature probe if it has one. Then place the sensor in the U-place holder. Neatly, Hans. There's a reason for the cable tidy channel. Switch it on and press mode until you're in pH mode. The device will start in manual temperature control mode by default. If your sensor has an automatic control, press read to set this function. As you can see here, the meter is reading ATC. This means the temperature is automatically set because the sensor includes a temperature probe. If your sensor doesn't support this function, you can set the temperature manually by pressing Menu, then selecting Temperature Settings, then setting MTC Temperature. See? We said this was easy. The next step is to set the stability criterion. Ooh. This controls how accurate the sensor will be. It's all about speed versus accuracy. Imagine this time we're using an automatic tuner for the violin. The fast setting offers a quick result which isn't that accurate, so the music sounds okay, whereas the strict setting gives a highly accurate result, but it takes longer to make the measurement. Standard is a good choice for normal measurement and calibration. It's important to bear in mind that if you have an unstable sample, using the strict setting may result in never obtaining a reading at all, in which case it's best to use the standard setting or fast for very unstable samples. The next step is to choose the buffers required to tune the calibration. Uh-oh, Hans. Sounds like more science. Buffers are liquids with known pH values, which act as reference points for the meter to compare its actual measurements, like with our violin and the reference pitch of the tuning fork. If you know roughly what the pH of your sample is going to be, then you may use two buffers for a two-point calibration. In this case, choose buffers with pH values that bracket the sample value. It's recommended that the difference does not exceed 4 pH units. So, for example, if you were measuring some nice fresh orange juice, which is about pH 3, then you would bracket with buffers pH 2 and pH 4.01 for best results. If you have no idea what your sample is going to be, or if you're going to be measuring samples with varied pH values, then it's best to use a multi-point calibration to provide a wider calibration range. If you measured these varied samples with only a 2-point calibration and the pH sample happened to be out of this range, the reading would be inaccurate. We use a 3 or more point calibration to provide a wide range without affecting the accuracy of the measurement. It's like tuning all the strings on the violin instead of just one. This allows us to hear more music. No, Hans. Later. You can set the buffers you wish to use by choosing Calibration Settings, then Buffer Group, then choosing from the list of standard buffers. It's really important you make sure the buffers you select include the ones you're actually using, or you'll get inaccurate results. By selecting the right buffer group, you're telling the meter to account for the temperature dependency of the buffers in use. Next, you can select from two calibration modes. Linear calibration is the more common mode, whereas segmented mode is best suited for wide pH ranges, including very high and low pH values. Phew! Okay, Now that the meter is set up, let's get hands-on and prepare that sensor for action. When you plug the sensor into the meter, the sensor's ID is helpfully displayed to help prevent little accidents, like using the wrong sensor, right Hans? If you're using an ISM sensor, the ISM logo will also appear in the display, and the sensor may display a condition icon, which indicates the condition of the sensor and if it needs cleaning or replacing. This icon may not appear till after calibration, depending on when you last calibrated the sensor. If your sensor has a liquid electrolyte, then make sure you open the filling hole before measurement or calibration. Check the electrolyte level, remove the wetting cap, and make sure there are no bubbles inside the lower part of the sensor near the membrane or diaphragm. You can now put the sensor into position and rinse it thoroughly with distilled water. Use a clean tissue to remove any remaining drops. Careful, Hans, it's not an espresso maker. The sensor membrane is very sensitive to touching or scratches. It's almost time to dive in, but before we do, it's important to note that using fresh buffers is highly recommended. Sachets are guaranteed to be fresh. New bottles are too, but they must be closed immediately after use and marked with the date and time. Just like fine wine, although buffers don't get better with age, so check that expiry date. When you have poured a buffer for use, don't try and pour it back in, as it may introduce contaminants to the bottle. Okay, Hans, the big moment has arrived. It's time to perform the calibration. Starting with the lowest value pH buffer, lower the sensor tip into the buffer until the diaphragm is fully immersed. As a rule of thumb, the electrolyte inside the sensor should always be at a higher elevation than the sample solution when immersed. Now press Cal to start the calibration of the first point. You'll know when the calibration for this buffer is complete because the flashing A will change to A rooted. Now you can remove the buffer, clean the sensor like before, and either save the result or press Cal to continue the multi-point calibration. When the last buffer has been measured, you can press Calculate to see the new sensor values which you've measured, including the slope and offset values. These can be saved by pressing Save. Congratulations! You've now completed your very own calibration. Now you can get to work measuring your samples. Well done, Hans! Give them a clap. Thanks for watching.